All right, so first step is to find our critical numbers. Do note that the domain of this function is not all real numbers. We do have a radical, and when you have a radical, you need to make sure that that quantity is greater than or equal to 0. So the square root of t would mean that we need t, the radicand, to be greater than or equal to 0. All right, so the domain is not all real numbers. We are only looking at values of t that are greater than or equal to 0. So we carry on with our critical numbers. So for the critical numbers, I'm going to take the derivative. Of course, I would need to rewrite this square root as a t to the 1/2 power. So this is going to be f prime equals, the first term is linear, so it goes to the coefficient, plus, and then I multiply 6 times 1/2 to get 3t, and then take 1/2 minus 1, that becomes a 2/2 to get a negative 1/2. Now, what I want to do is I want to set the derivative equal to 0 or the derivative to does not exist. To do that, it really amounts to setting the numerator equal to 0 and the denominator equal to 0. So when I have these negative exponents, I do not want to keep them. I want to rewrite this as a fraction. So what we're going to do is we are going to get rid of the negative exponents as soon as possible. So this first term, this -2, does not have a negative exponent. It's perfect. The second term has the negative exponent. Remember that the 3 is separate from that t to the negative 1/2. So this is going to be 3 over t to the 1/2. Now, ultimately, my goal is to set numerator equal to 0 and denominator equal to 0. So a lot of times what's going to happen is we're going to need to get one fraction. And the way we're going to get one fraction is by getting an LCD. So here my LCD is going to be t to the 1/2. So what will happen is my derivative, this -2/1 term, will need to multiply by t to the 1/2 over t to the 1/2. And then the second term has that LCD, so it is good to go. Once we have the LCD, we will then write this as -2 t to the 1/2 plus 3 all over t to the 1/2. And now we have our one single fraction where we can set the derivative equal to 0. That amounts to setting numerator equal to 0. And we can set the derivative to does not exist. That would amount to setting the denominator equal to 0. So with the numerator equal to 0, we are going to be looking at -2 t to the 1/2 plus 3 equal to 0. And then for the denominator equal to 0, we will be looking at t to the 1/2 equal to 0. All right, so what will happen here for this first, remember you really just have an equation where you're trying to undo PIMDES. So what I have is like I have this isolate the parentheses to a power, but really think about it as I'm trying to undo PIMDES. So my first step is going to be to subtract 3 from both sides. Then I'll try to undo the multiplication and division. So I'll divide both sides by -2 and get t to the 1/2 is equal to 3/2. Now, to undo this exponent level, the way that we undo the exponent is we raise to the reciprocal power. So when I have the t to the 1/2, to undo that, I am going to square both sides. And then the 1/2 and the 2 will cross out, and that will give us t equals. Keep in mind for this 3/2, you do need to distribute the 2 exponent to both numerator and denominator. So that will give you 9/4. And that is in the domain, so that would be considered a critical number. Meanwhile, over here with this f prime does not exist, we have a t to the 1/2. We're right at that exponent level. So to undo it, we will square both sides, and that will give us t is equal to 0. Now, technically, t is equal to 0 is not a critical number because it's not interior to the domain. However, it is still relevant for potentially finding an extreme point. So we are going to potentially consider it, but the reality of the matter is it's not a critical number. And so there's two ways that you can do this, and I think I'll do a separate video on the next page to explain that when we draw our number line. But I just want to mention here, this 9/4 is a critical number. T is equal to 0 is not a critical number because it's not interior to the domain. Because remember, we had that our domain was that t is greater than or equal to 0. So if you go back to that picture that I had, we had 0 included and then everything to the right. So 0 is actually the end point of the domain. It's not a critical number.